Okay, so when we talk about the intersection between AVSs and this agentic world where we see lots of agents and they interact with each other, and how and what role AVSs can play in this agentic world.
I walk here, it's okay?
Oh, no problem.
Okay, well, let's start with the definition of an agent. So here is the received version, for the lack of a better word. People say, hey, bots are something that's automated, while agents are something that you call autonomous. Now, what I mean by this is that if you think about agents, they basically have a certain goal that they want to achieve. So, for example, let's say if you're building an agent that is supposed to do portfolio management, then the goal is to, for example, get the best APY for a certain asset. And they may have certain preferences. For example, they may say, okay, my agent is not supposed to take risky bets, and it's only supposed to get an APY that's safe enough. And then they have certain abilities, right? So, for example, they're allowed to go and connect to MetaMask, so they have some access to certain addresses, and they're able to connect with RPCs and whatnot to send transaction and interact with the smart contract. And they may have certain prior knowledge that, hey, maybe this protocol or this DeFi protocol is broken or was recently found to have some issues, so do not interact with this specific DeFi protocol. And then they take actions in the environment, which is the blockchain, and then they can adapt based on the experiences that they get from that agent, from that interaction. So this is basically what it means. This is how we understand what autonomous means in the world of agents. And here is a proper, I would guess, agentic definition or recursive definition of agents, which is that agents are something that express agency, while bots, well, they don't have any agency. But the question is, what does it mean to have agency? What does it mean to express agency? And this is depends on who you talk to. If you talk to computer scientists, they will have probably a different definition of agency compared to if you talk to philosophers. And this is kind of a distilled down version of what the definition of agency is in the philosophical context. And what I mean by philosophy here is like it's a context that applies not just to machines, but to humans, animals, and things of any kind. And so, what does it mean to have a human, animal, or a system to have agency? The first is it should be able to set some meaningful goals for itself. And that has to be deliberate, in the sense that it must think about, here's what I want to achieve, and here's what my task is, and what this is my end goal. This agent must be, or this system must be able to make choices, and they have to make choices to be able to reach that goal. And again, it has to be able to decide. An important part of that, it's not about, here's what I have to achieve, but it's also about, it should resonate with certain internal values and principles. So, for example, let's say this agent wants to do a revolution, for example, it must have this belief system that says, okay, I want to achieve this because of certain good that I want to achieve in the world. And so it must have certain principles and values underneath that pushes the agent to take that action. And whatever action it takes, there's a certain reason to it. It's not a mad person. It has this, whenever it takes an action, there's a logical explanation to that action. So there's an intention behind each action. And then there's a desire, but this is very important. It has been seen among certain kind of animals as well, which is that many agents, you could see that in sort of sci-fi movies where agents go completely against humans. The idea that agents should be able to influence other agents, and they should have this desire to influence other agents. So, for example, if you are trying to do a revolution, or if you're an agent that wants to do that, then you should have this belief that it's not going to be possible unless I convince 10 other people to join my mission. And that's what this influencing means. And then the last part is that it should be able to self-govern. And again, this means that you look at the environment, you take certain actions, you learn from that environment, and you're able to change your principles and values. And so you should have this mental attitude that says, okay, fine, this is what we have been trying, it's not working. I have to, or this world has changed entirely, and so I have to change my values as well. And again, this is not a kind of a quoted definition, but this kind of gives you an idea of what agency actually means in the world of philosophy. Now, again, it still may not be clear what agency and autonomy means, or what's the difference between those two. So here's kind of a bullet point list of what I mean by this is agency and this is autonomy. So in agency, you basically start with a goal and you take initiative, right? And a lot of people say, hey, we want to hire people or engineers with 10x agency. This is what they mean. That they want to be able to find people who have the ability to take initiative, solve problems on their own, and be able to solve those problems. And so they should have this initiative ability, they should have this ability to instigate a change to pursue those goals. But in autonomy, you don't have that. You have the right and the ability to make a choice, but you don't create that initiative yourself. Okay, so that's what autonomy means. Agency usually has both internal as well as external outcomes. So for example, if you're an agent, you take a certain action and that will have outcome on the certain environment that you're playing with, but it also would influence you internally. So there's an internal state that changes based on the actions that you take, or based on the output that you get from those actions. Well, autonomy is mostly about taking outputs. So you impact something, you get an impact, and the impact is mostly visible in the external world. Agency is mostly about producing an outcome. So you kind of want to achieve something, and the process is not the real focus. Autonomy, as you can think about, like when you try a script, here's a script that does something. You're basically telling what the actual process is to be able to achieve that task. So focus is much more on the process, not necessarily the outcome. And finally, as I said earlier, agency means there's a certain internal motivation, there's an internal mental aptitude to cause a certain action, which is not available in autonomy. And that's kind of what it means by. So on the right side is kind of what you see with bots or some of the early agents, and what true agency means. Okay, so now whatever your definition is, whether you go by the received definition or you go by this philosophical definition, basically you are living in a world, we all live in a world where you will have this multi-agent systems where you have an agent A, agent B, agent C, they have certain capabilities, they have certain philosophies, and they will take actions based on those internal state of mind. And so they will debate with each other, they'll send transactions with each other, and they will do business with each other. And so the question is, why is it interesting in the crypto world? And one of the main reasons is that agents align very well with crypto rails, because a very simple way of thinking about this is that agents today, because they're not humans, they will not be able to open bank accounts. Right? And so the first alignment that they get is that they can actually have access to financial rails that is otherwise not possible. Agents, when they try to compose with each other, you want to be able to make sure that if I'm getting an output from an agent, I want to be able to verify this outcome indeed came from that certain agent. And to be able to build this trust minimized composable network of agents. And again, because of this openness of blockchain systems, you actually should be able to discover agents, other agents that are capable of doing certain things in a much more easier way, that is otherwise not possible in the Web 2 world. So you can imagine different kind of crypto agents. We may have seen this in the past as well, where the idea is like, hey, here's my asset, I want to sort an API, can you get me sort an API? You could imagine building auditors, testers that will check your code and be able to tell you that this code doesn't look good and you should go and fix it. But other things like treasury management, minimizing governance, so imagine AltLayer or Compound and those kind of protocols where instead of having Gauntlet and the big brains, you would have these agents that will potentially decide some of the parameters that should be adjusted based on what's happening in the protocol itself. And you could imagine agents being built in different, or deployed in different settings. The first setting is what I call customized for specific users. So imagine, let's say an agent that you want to customize for you so that it can serve your specific purpose. So imagine, I don't know, you want a health instructor, and this agent will somehow monitor your let's say blood, different parameters, and then it will suggest you a certain regime that you should follow. So that's something that's specified or very customized to you as a user. You could imagine a system where it is not customized for you, but it's integrated within an app. So it's customized for a certain service. So imagine something like having an agent that's deployed right within Aave or Compound. And the Aave and Compound basically takes a look at your transaction history and says, hey, given your profile, you don't look like a very risky guy, you should take and follow these strategies or something. And then you have these agents that can be publicly available for anyone to use. So there's no customization, it's not for service, it's a very generic agent. Kind of thing like ChatGPT in some way. And the agent that anyone can use without any customization whatsoever. Now, no matter what your agent deployment setting is, basically you're looking at 3 different phases of an agent. And this is kind of where we help with this product called Autonomy. But the idea is how people deploy agents, because in the end you have to deploy this agent either in a customized setting or in a service setting or in a public setting. So you have to build agents, deploy them, and then go to distribute them. So this is kind of what we're building with AltLayer. But one thing that's very important in any of those settings where you deploy is that how do you guarantee that the agent that you're talking to is indeed the agent that you're supposed to talk to, and it's not some random developer typing tweets on behalf of AIXPD, for example. And so there are two kind of properties that you want from what I call verifiable agency. Right? An agency that you can verify that's indeed a real agent and it's behaving in the way it's supposed to behave. And what is non-interference? That it's not supposed to be, no one is supposed to interfere with the outcome or the output that the agent produces. So it's truly autonomous, it's truly agents. It has its true agency. And the second is non-tampering, like you should not be able to tamper in any way whatsoever the underlying model itself. So you should not be able to do that. And once you have these two properties, what you get is verifiable agency. And again, when you're thinking about verifiable agency, you have to think about three different stages where you need this agency, verifiable agency behavior, which is one of the deployment stage, which is like when you're deploying an agent, we're asking someone to deploy an agent for you, you're going to make sure that it's indeed a copy or indeed the same agent that you wanted to deploy. And the second is invocation, which is when you want this agent to be able to process some requests or be able to process an inference, you want to be sure that the output that comes out is indeed an output that came from that specific agent. And finally, updates. So if the agent is being changed or updated in some way, you want to make sure that that is done in a much more transparent way. And that's if you verify these three stages, then what you get is verifiable agency. Now, here's a way, and by the way, there are different ways of verifying agency. One is, for example, people are talking about ZKML and things like that. Which is it's promising, but it's not quite there in the sense that there's no way you could take an old model or any other models that are being built by OpenAI and be able to put that ZK file. It's just impossible, given the sheer size of the systems that are there, the parameter size. So one way you could achieve verifiable agency is through using trusted hardware, or otherwise called, let's say, AltLayer. And the idea is to have your agent running in a TE prover, and then you have user on the other side, and user would then make a request saying, hey, I want to deploy this agent. Can you give me a proof that this agent was indeed deployed? And then the deployer would then start this enclave where the agent will sit and get deployed. It will produce a report, and that can be verified. You could verify it locally if you wanted. If you want it to be composable with the other agents, then you could send this proof to Ethereum or any chain, and then other agents can verify this proof and then can act upon it. And so you get this verifiability at the deployment stage. And then after that, whenever you make a request for an inference, you send a request to the agent. Again, that's running in TE. The TE will then produce a hardware proof that you can verify, again, either locally or you could put that in a contract to verify. And so this is how you achieve verifiability using a trusted hardware. There are certain caveats in the sense that many systems, the way they produce the hardware proof is actually quite big, and so you cannot directly verify that on Ethereum or any L1 directly, and so many systems actually ZKify it. So you don't start verifying the proof, it's the certificate itself. You actually verify that the ZK variant of that, so you just verify the ZK proof instead of the entire certificate. And here's an application where it's actually being deployed today. So this is a protocol called Automata. And the idea is they are building this with an ABS. So you have, let's say, 5 different operators, and 5 different operators could be running different kind of trusted hardware. So one could be running, let's say, Intel SGX, the other one could be running TDS, and so on and so forth. And then you have some sort of a BLS signature scheme that allows us to vote, allows these operators to vote on whether the agent is actually running what it's supposed to run. So even if you have one of the operators is down or has been hacked, so for example, if somebody is able to extract the private key or the transition key that sits on this hardware, you still have the other operators can still verify to the fact that this is indeed a real agent. Now, there's a second component where you can actually use ABSs in the agentic world. So far, what you get from Intel SGX or the trusted hardware is the security component, that the agent is actually the agent that you want to interact with. But it doesn't give you liveness guarantees at all. So imagine, let's say, if you have one single agent, one agent running in a single hardware, then you would, if that hardware goes down, then basically your agent won't work. So the idea is, can you bring, liveness or some sort of availability to these systems that could be very useful for end users. And so, why would you need kind of liveness guarantees from agents? One, because you could imagine an agent that handles your port position or RV position or so on, and you want to avoid liquidations. And so, this agent must have this ability to be able to sign and close or put more collateral and so on, and be able to close that position if needed. And you can't do that if the agent is just not available. You could imagine maybe there is a big ICO happening or NFPCL happening, and you want to be able to get whitelisted for that sale, and you don't want this agent to be unavailable if that happens. You could imagine avoiding rugs. So imagine a scenario where somehow it's been known that this project is going to rug in the next, half an hour, or it's actually getting a slow death, and you want to be able to pull your funds, before it actually goes to zero. So imagine Luna kind of system. So you want to be able to have this agent that actually is live and acting upon those market signals. And so this availability becomes critical, because otherwise those time-sensitive tasks will not be completed, and you will have social and financial impact. And one way to kind of fix this, or be able to at least supplement this, is by building an AVS, which would be a bunch of operators which act or check the heartbeat of this agent. So they basically will ping every now and then and say, hey, are you alive? Are you still responding? Through sort of kind of telemetry APIs that we use. And it's kind of like a watchtower network. This kind of exists in the blockchain world today as well. So if you imagine you have a roll-up, like an optimistic roll-up, the sequencer and the validator are actually taking those transactions, executing them, but at some point someone has to be there to be able to say that this state root that was posted on Ethereum is actually not valid. And this is why you need this network of watchers that will keep the sequences and validators in check. And so this is kind of where Pulse comes into play, where Pulse acts an ABS as a watcher to make sure this agent is actually live, and it will inform you, hopefully way ahead in time, before the agent actually goes down. So imagine an agent that is not very responsive. It goes down every 2 days. You would rather not interact with it. And this is kind of what this Pulse can give you as a guarantee. So yeah, you would have a bunch of operators that will have access to sort of APIs that this agent offers, and then these agents will then, these operators will then check those APIs as active and responsive, and then they would then agree that this agent is still alive. So yeah, one quick benefit of Pulse as an ABS is that it gives you this continuous monitoring and reporting system. And so if something goes wrong, you would actually be alerted much more earlier than at the social layer. If it could prevent you financial loss. So if you have this agent that goes very frequently down, then you'd rather not use this agent for any mission critical system. And it builds trust and transparency for your agents as well. Well, that's mostly it. Thank you very much. I'm happy to take any questions.
Hey, let's give a round of applause for Amrit, please. And we'll go ahead. Do you guys have any questions for Amrit? No. Amrit, do you have any questions for them?
Well, who is building an agent?
Yeah, who's building an agent here? Who's even played around with building agents yet? Okay, we got 1, 2. That's it.
What is the biggest concern other than getting users?
Repeat the question again.
What is your biggest concern if you're building an agent? What's your biggest concern when you're building an agent, which is different from kind of, okay, I have to get users, but what is the other biggest concern beyond that?
Does anyone have any major concerns about building agents?
You've been designated to answer this question.
Okay. I guess looking at what decisions the agents are making, how do we have an audit trail, how do we stop them from hallucinating and doing something stupid, keeping some guardrails in place.
The reason why I'm asking is because, again, the idea is like you want to build those system infrastructures that can actually help people solve those problems that agents will face today. And hallucination is a big problem as well. I mean, I mean, my view, I was on a panel earlier today, and there was a question, okay, how do you fix hallucination? And for me, personally, I feel like hallucination is a property of the model. Like, if the model doesn't work, it will hallucinate, right? And so the only way to fix, for example, something like hallucination is basically through feedback, where let's say you have an agent that you as a user interacted with, and this agent is giving you weird response and whatnot. And if enough people are getting similar responses, then you could have this feedback loop where it goes back to the model and the model basically learns from it. And you could do that in, the main concern there is, okay, maybe I don't want to share the queries that I made with this agent because it's very private. And then they could have models where, you could imagine systems where it's privacy preserving, where you actually feedback the system again in a privacy preserving way so that the model actually doesn't learn your query, your inference request. Yeah, so I would say hallucination is a problem, and I think, but it's a problem for the model itself. And I think the way to fix this would be kind of feedback back into the model.
Does it make any sense that, like, if I'm using an AI agent, as a user of AI, I don't really care that AI hallucinates sometimes, as long as I'm not doing anything with that information. If I have AI set up to help me to, I don't know, to automate some wallet processes or transactions or something, I can build it in a way so that my users, they have AI to kind of help, but they have to kind of, push the button to, actually do something, or I don't know. Does this make any sense? Like to have some type of like you're in control of kind of what the AI does. It can help you, but you ultimately have the control over, asking it to do something additional.
Yeah, so basically you're proposing a model where let's say you are a user, you make a request to an agent, and then agent prepares you something back, and then you validate before it gets triggered. There's another model that some people have built, is where this is master-slave model, or it's a parent and children model, where you have this master agent that you actually interact with, and it gives you sort of inference, and then you ask the slave agents or these children agents to read on the same thing as that again. And then you say, okay, fine, looks like there's something weird going on because the answers don't match. If they don't agree, then it's okay, fine, the master really has to be hallucinating. So you feedback or change something else and so on. So yeah, the answer is right. You would rather, the simplest way to do this is, okay, fine, I'm going to validate before I actually press the button.
I was going to make a comment on that. Anyways, I'm not going to do that. All right, cool. Any more questions? All right.
Thank you very much.
Amrit.
Thank you.
Great presentation.